video presentation of our face recognition project. So what is that? Remember when you're using your phone gallery and there is a folder, for example, people and pets? Sometimes when you want to find someone's photo fast, it is very useful. So the idea of this division by faces is made based on face recognition. Aim of our project. Our project explores various methods for face recognition with strong emphasis on linear algebra. We focus particularly on how dimensionality reduction techniques, especially principal component analysis and linear discriminant analysis, can enhance model efficiency and interpretability, while also comparing these methods with modern deep learning approaches like convolutional neural networks. Here you can see a data example of our dataset, which includes 10 people, each of them with approximately 100 photos. So our main approach is to implement and evaluate various dimensionality reduction techniques, for example, PCA, LDA, SVD, NMF, and classification methods, for example, KNN, for face recognition. The project focuses on pre-processing image data, extracting meaningful features, and optimizing classification accuracy by reducing the feature space while retaining discriminating information.
So a little more about the approach. Firstly, we have the data preparation. We have the dataset loading. Images are loaded from the dataset directory, resized to a consistent dimension, converted to a grayscale, and flattened into 1D arrays. Label mapping. Each person in the dataset is assigned a unique label for classification. Pixel values are normalized to a range of from 0 to 1, and standardization is applied to assure zero mean and unit variance. Dataset splitting. The dataset is split into training and testing sets to evaluate the model's performance. Here is the example of our mean phase and phase variance. Next, dimensionality reduction. For the PCA is used to reduce the dimensionality of the image data while retaining the most significant features. Eigenfaces are computed to represent the principal components of the phase dataset. The number of components is optimized to balance computational efficiency and accuracy. Linear discriminant analysis, LDA, is applied to maximize class separability by projecting data into lower dimensional place. It is used either standalone or in combination with PCA. Classification. KNN, a simple distance-based classifier, is used to identify the closest match for a test image in the reduced feature space. Custom implementations. Algorithms like PCA and LDA are implemented from scratch to gain a deeper understanding of their mechanics. Evaluation. Accuracy measurement. The system's performance is evaluated by comparing predicted labels with true labels on the test set. Visualization. Class distributions, mean faces, and variance are visualized to understand the dataset. Results of classification are displayed with the simple images and predictions. Optimization. Component selection. The number of PCA and LDA components is optimized to achieve the best trade-off between accuracy and computational cost. Dimensionality reduction techniques. Other methods like SVD and non-negative matrix factorization are explored for comparison. And pipeline integration. A complete pipeline is built to preprocess data, apply dimensionality reduction, train classifiers, and evaluate results. The pipeline is optimized for speed and accuracy with option to test different configurations and methods. But how?
So the basic algorithms that we choose were PSA, as already mentioned, LDA, and CNN, and NMF. They are quite different. Also, we combined them with other and experimented a little bit, but work is still going. So PCA, we already heard about it. It's principal component analysis. It works that you project face images into lower dimensional space by maximizing variance. Represent faces as a combination of Eugen faces. Then the recognition it happens by comparing distances between projected vectors. Our basic implementation works based on the covariance matrix, and by using it, we find Eugen faces, but it's not the most optional method. And Nadia Leskovska said that we should try use SVD, and also our mentor told us to do that. So we are now implementing SVD. LDA is usually mentioned with PCA. It's a linear discriminant analysis. It projects its faces to a space that maximizes class separability, uses both within class and between class scatter information, and recognition compares positions in discriminant space. So it's both about spaces. Um, yeah. NMF, it's quite a new thing. So it has three parts. The input matrix X, which is the photo face, is factorized into non-negative matrices V and H. V is parts and H are coefficients. Initially randomly, initially random. Iterative updates. So the algorithm iteratively updates V and H using multiplicative rules to minimize the approximation error between X and Y multiplied by H. Convergence. The process continues until the error Frobenius norm between the original matrix X and its approximation is sufficiently small, or the maximum iteration are reached. Uh, if you remember our second or third lab based on SVD, it's kind of similar how you were doing it with QR factorization if you were doing it like that. So it's quite a similar thing, but does the others. CNN is quite different from what we got before because it's more complex way and it's hard to understand from the LA logic idea. So it learns hierarchy features of faces directly from pixel data, produces face embeddings through deep layers without manual feature extraction. Recognition is done by comparing embedding vectors and the most effective and it's used best at the face recognition algorithm. So probably your phone uses it. Also, our mentor told us to try to apply PCA plus LDA. It's still we are fixing it, but we already have big part of it. So evaluation criteria are well known for all of you. It's accuracy, precision, recall, F1 score, confusion matrix, and processing time. So I think most of you know it. If you don't, you can stop the video and read about it. Comparison. So as I mentioned in CNN, all the algorithms before are more aimed to the usage of linear algebra. Right now, mostly algorithms of face recognition are way more complex and they don't look like that. Um, Also, here is mentioned that we have some problems with the running of code because we use Python, which is not the fastest language, and also we are trying not to use the implemented into Python libraries, so it takes a lot of time to run all of that. Um, it's an example of running on one simple on one time of each of these tests, you can see that CNN has the highest accuracy but far more higher time. We are still fixing all of them and trying to make them better, but it's still ongoing. Thank you for your attention.